Hello everyone, welcome back to the series of lectures on chemical bonding. In today's class, we are going to discuss about valence bond theory and the concept of hybridization. In the last two lectures, I discussed the Lewis theory and the valence shell electron pair repulsion theory. These two theories are classical theories. So they regard electron as a particle. They don't consider the wave aspects of the electron. On the other hand, valence bond theory and molecular orbital theory consider the wave nature of the electron and the wave mechanics developed by Schrodinger. In 1926, Schrodinger developed wave mechanics of electron. So Schrodinger showed that there is a wave function associated with the motion of the electron. This wave function was termed atomic orbital. Hitler and London joined the research group of Schrodinger in 1927, and they are interested in understanding the chemical bonding in hydrogen molecule using the wave theory of electron developed by Schrodinger. So they worked on this problem and they showed that a chemical bond in hydrogen molecule is formed by overlap of the atomic orbitals and exchange of the electrons of opposite spins between the two hydrogen atoms. So let us try to understand this in a more detailed way. So there are two atomic orbitals, one phi A, other phi B. Phi A on first hydrogen atom, phi B on the second hydrogen atom. Each has one electron. Phi A has electron with spin up direction, that is clockwise spin, and pi B has electron with spin down, that is anti-clockwise spin. When they overlap, there is an exchange of spins between the two atoms. So the pi A spin becomes anti-clockwise and the pi B spin becomes clockwise. So this is responsible for bonding in hydrogen molecules. So the bond is formed by the overlap of the atomic orbitals and exchange of electron spin between the two atoms. So the overall molecule can be described as a combination of these two spin paired forms. This combination is termed resonance. So the wave function of the molecule, hydrogen molecule, is a resonance between the two forms. The first form is phi A1, phi B2, and the second form is phi A2, phi B1. So first electron in phi A, second electron in phi B. This is the first representation, and the second representation, the electrons change their positions. Second electron is in phi A and first electron is in phi B. So the combination, the linear combination of these two represents the actual wave function. One limitation of this theory is it accounts only for the sharing of electrons, that is the covalent bonding between the two hydrogen atoms. It does not take into account the ionic bonding. So later in 1931, Pauling and Slater developed the concepts of covalent-ionic resonance and the hybridization concept. Pauling proposed that in addition to the covalent structure, we can also have two ionic structure. Two electrons lie on the phi A orbital and phi B orbital is empty. On the other hand, we can consider the other case where the two electrons lie on phi B orbital and phi A is empty. So these two are two different ionic terms which should also be incorporated into the overall wave function of the molecule. So the overall wave function according to Pauling is a combination of three terms. The first term is the Hitler-London wave function, which accounts for the covalent bonding in hydrogen molecule. And the second term and the third term are ionic terms, one in which the two electrons are on HA and the other one in which the two electrons are in HB. However, in case of hydrogen molecule, Pauling assumed that these two structures are negligible. That is, the ionic structure contribution is negligible. Therefore, we can still say that the overall wave function is the Hitler-London wave function or the covalent wave function. And for also other molecules like Li2 and fluorine, which are homodiatomic molecules, that is, the both the atoms are same, then we can ignore the ionic contributions. This is the assumption of Pauling. However, when the two atoms are different, like hydrogen chloride, CF, in such cases, we cannot ignore the ionic contribution, and the overall wave function should be a combination of the covalent function and two ionic functions. In such cases, the resonance between these three structures, covalent and ionic structures, explains the bonding in that particular system. And the resonance energy between the covalent and ionic structures, it is proportional to the difference in electronegativity values. That is, if there is lot of difference in electronegativity, for example, let us say we have one hydrogen and one fluorine, then the covalent ionic resonance is relatively large. So the contribution of ionic structures is significant. So these are the assumptions of Pauling's and Slater theory, which introduced this concept of covalent ionic resonance between covalent and ionic structures into the original valence bond theory developed by Hitler and London. Later, Pauling developed the concept of hybridization. So how this concept originated, let us see now.